Okay, in the case, so your differential equation is going to be, well, okay, in the case where the inflow is of pure solvent, then the concentration of the inflow is 0, and your dq dt is just going to be equal to the negative q over v of t times r, where r is rate out. Okay, so we could say that, okay, this is rate out. Now I leave off the subscripts. V is going to be the volume of the container, and R is going to be the rate out, since we don't have a rate in to distinguish it from. In any case, here's your differential equation. If the container is initially full, then V of t is equal to volume V of the container. So your dq dt will equal the concentration, Q over volume of the container, times the rate out, and it'll be the negative of that, because of course it's flowing out. You talk about what's flowing out here. So this equation very easily rearranges to dq over q equals negative r over v dt. That is, the equation is separable and it's easily solved. So the solution, well, left-hand side has an integral for an antiderivative that's a natural log of the absolute value of q. Right-hand side has no t dependence, it's just negative r over v times t plus a constant. So we have this solution, meaning the absolute value of q is e to the negative r over vt plus c, which is a e to the negative r over v plus c. That v is hard to read, maybe still hard. Where a is greater than 0, a being e to the c, which is always non-negative. Okay? So a has to be positive. However, you have absolute value of q equals this, which means that you could also write this as q, well, okay, absolute value q could either be q or negative q. So your solution could actually be q equals a e to the negative, etc., or negative q equals this, which means that q would equal negative a e to the negative r over vt. Well, this a is a positive constant, and now you can have a positive or a negative for a. And I actually wrote this down wrong. I said a from negative infinity to infinity. This is just a not equal to 0. I wanted to emphasize that a could be positive or negative now. We could just, if we remove the absolute value sign, then we could have had a positive or negative q here, which means if we just write q here, we could have this a, or we could have the negative of this a. So as long as a is not equal to 0, any value of a now works. Now q of 0 we take to be q naught, so we have an initial condition. That means that when t equals 0, we get a e to the negative r over v times 0, which is just a, and that's got to be equal to q naught, so a equals q naught. So now your q function, your concentration, is just this decreasing exponential, e to the negative r over v times t. Now we're going to apply that to the Dr. Pepper situation we started with.